Hello and welcome to NASA's Kennedy Space Center in Florida for our pre-launch coverage of CRS-17 by SpaceX and NASA. As the name suggests, this is the 17th resupply mission to the International Space Station by SpaceX. I'm Daryl Nail with NASA Communications, and we have guests here to help us break down this mission, and so we want to go over those now. To my left is Kenny Todd, the manager of International Space Station Operations and Integration at Johnson Space Center. And we have Hans Königsmann, Vice President of Build and Flight Reliability for SpaceX. Also, Will Ulrich, Launch Weather Officer for the United States Air Force's 45th Space Wing. And on the phone, we have Kurt Costello. He's the Acting Chief Scientist for the International Space Station. Now, we're going to take your questions in just a bit, but first we want to start with opening statements. And Kenny, why don't you get us started?
All right. Good morning to everyone. It's great to be here. Very excited about the opportunity to get this SpaceX 17 mission off the ground tonight. Hopefully, with the weather will cooperate with us and we can get going. I was just out at the pad a few minutes ago watching the closing parts of the late load for our cargo that's going in, which was kind of cool because a lot of that cargo is some of our critical research that we want to carry out over the next 30 days. So it's great to see it going in, and I can't wait to see the hatch open here in a couple of days, and we can get working on it. So this particular Dragon, we got about 1,700 kilograms worth of cargo for the ISS on there. When you take that coupled with the cargo we brought up a couple of weeks ago on the Cygnus module, about 4,800 kilograms of cargo. So needless to say, the crew's very busy right now. They're enjoying it. This is a fantastic crew on orbit, and the more you give them to do, the more they do. So it's pretty incredible how well they're working together. As far as the increment goes, this is going to increment 59. We got about 7 weeks left, so I think we won't have any trouble getting this mission done in this increment, and then the majority of the Cygnus mission done as well. So June 24th is currently our plan to bring Ann and David and Oleg home, and that'll close out this particular increment. From a space station standpoint, I'm happy to report that things are a lot better today than they were yesterday at this time. As most of you have known, early Monday morning we got a surprise with the loss of one of our main bus switching units. There's 4 of them on station, and we lost the one that helps feed power from channels 3A and 3B. And so we had to essentially try to look at all our options. Could we live with this problem? Could we go do this mission, knowing that we only had 6 of 8 power channels, and we exhausted all of our options quickly in terms of trying to cross-strap power to allow us to get the power redundancy we need for some of our critical systems. So once we exhausted those options, we then had to look at our best option to try to replace the MBSU. We decided these particular boxes, we've replaced one robotically. We've also done one via EVA, so we knew that we had both of those options available to us and in our toolkit based on our experience with those particular boxes. In the end, we decided the best course was to do it robotically, and we challenged our robotics team, and I'm talking about the team here as well as our friends and our partners in Canada who have the responsibility for that arm. And they just did a fantastic job since this problem occurred in pulling together all the necessary products and procedures and putting us in a position to be able to go execute that operation yesterday. So about 5 a.m. this morning, Florida time, I got the thumbs up that things were in good shape and we're back to having good redundancy from a power standpoint. So that puts us in a lot better position and ready to go do this mission. As far as the rest of the station, everything else is on track. Everything's working well. No huge anomalies that stand in the way of us doing the mission. The last thing I'll bring up is I know there's a lot of conversation and talk about what happened with the Demo 1 capsule. I know Hans is going to talk about that as well. But from a NASA perspective, we have worked very closely with the SpaceX team. Our first goal when this incident happened was to try to find out from a station program's perspective, do we have any issues with this particular Dragon? And very quickly, we partnered well with the SpaceX team. They were thinking the very same thing, and so we were able to get our arms around the common areas that we had to look at, that they had to look at, and at the end of the day, we didn't see any change in our overall measurable risk in going into the mission as a result of that. And so anyway, I just wanted to get that out there now. Again, I know there's a lot of conversation about it, but we looked very hard from a space station program at what that particular issue meant for us. I know all our friends in the commercial crew program, obviously they're very interested in what happened with that particular incident, and they're also very closely aligned with the SpaceX team and their investigation, and that's going to continue to go on for some time, and that's we'll let our commercial crew program go work with SpaceX and try to figure out their path forward. But we feel very comfortable in moving forward with this particular mission. So that I'll pass it on to Hans.
All right, thank you very much, and good morning. I'm happy to be back in Florida for another launch. I do want to start today with by addressing the test anomaly that occurred on April 21st this year. And please keep in mind, this is still very early in the investigation. The investigation is led by both SpaceX and NASA. Both teams are carefully reviewing the telemetry data and all the data that was collected during that test, high-speed imagery, telemetry, and it will include eventually the analysis of the recovered hardware from the test. Priority at this moment is to allow the teams to conduct thorough analysis before we come to any conclusions. That said, here's what we can confirm at this point in time. At the test stand, we powered up Dragon, and it powered up as expected. We completed tests with the Draco thrusters. The Draco thrusters are the smaller thrusters that are also on Dragon 1 and the Cargo Dragon. We fired them in 2 sets for each for 5 seconds, and that went very well. And then just before we wanted to fire the Super Draco, there was an anomaly and the vehicle was destroyed. There were no injuries. SpaceX had taken all safety measures prior to this test, as we always do. And because this is a ground test, we have a high amount of data, a huge amount of data from the vehicle and the ground sensors, but it is too early to confirm any cause, whether probable or root. But the initial data indicates that the anomaly occurred during the activation of the Super Draco system. That said, we're looking at all possible issues and the investigation is ongoing. We have no reason to believe that there's an issue with the Super Draco themselves. Those have been through about 600 tests at our test facility in Texas, and you also know about the paddleboard. We did some hover tests, so there was a lot of testing going on the Super Draco. We continue to have high confidence in that particular thruster. And as you mentioned already, Crew Dragon is built upon the heritage of Cargo Dragon, but these are different spacecraft. Dragon does not use Super Draco and its propellant systems. We have looked at all the common links between the two spacecraft. We had viewed that, and we approved for flight. We approved them for flight by both teams, NASA and SpaceX in common. Also want to point out CRS-17, that spacecraft has flown a CRS-12 already, which means it has been tested very well, like a flight basically. Yeah. Again, like to reiterate, the anomaly occurred during a test, not during a flight. That is why we test. If this has to happen, I'd rather it happens on the ground in the development program, and I believe what we learned from this test will make us basically a better company, and Dragon 2 at the end a better vehicle, a safer vehicle. And so we will take the lessons learned from this, and I'm convinced this will help us to ensure that Crew Dragon is one of the safest human spaceflight vehicles ever built. So that said, back to the mission at hand, CRS-17. I do have a few slides here. There we go. Targeting a launch at 3:11 a.m., which is an unfortunate time in the middle of the night. That's how it is when you want to, berth at the space station. You got to go over the space station, and the plane crosses the launch site at that point in time, more or less. So that's our launch time. I think the backup day is, I want to say 2:48, something like that. 20 minutes roughly per day shift. We started late load of cargo yesterday night. I saw them basically finishing up on the launch pad when we drove by. The vehicle will go vertical later today. Let's see, I already mentioned this was the same Dragon as flying on CRS-12 in August 2017. It's the sixth resupply mission that uses a previously flown Dragon spacecraft. And then CRS-17, as the name implies, is the 17th of up to 20 missions to the ISS. Next one, please. Yeah, this is hard to read for me. But I do want to just point out a few things on this one here. So we start loading the first stage as T-minus 35 minutes. And what always amazes me, and I've been through a lot of these launches, is that we start loading the second stage at T-minus 16 minutes. Sounds like a short time. On the other side, we empty the stage in actually less time than that. So you got to put those in relation. It's chilled lock, so you want to load it fast, and then you want to go basically right at that time. That's how we launch our rockets and Dragon, obviously. Then again, at 1 minute before launch, the vehicle takes over completely, and we start pressing up for flight. Next one, please. In flight, pretty much like all the other flights, we will return the first stage and attempt in this case, drone ship landing, but pretty nearby. Both landing and orbit insertion always happens at almost the same time. I'm always torn what to look at, basically, but first stage lands a couple seconds before the second stage engine cutoff happens, and then after that, Dragon deploys and from the stage and goes on its mission. And then let's see, the last one is last slide, please. That's an inspirational video. You see a little bit how Dragon basically limits cycles before it gets captured by the arm, and then the arm moves it over to the node 2 Zenith. Sorry, Nadir, not Zenith. And docks the spacecraft. And if you were to look from the door, that's how it looks in the last cut here. 1 second. Yeah, exactly. That's how it looks if you were inside the door and you see Dragon berthing as it comes closer and closer. That's all I had for now. Thank you.
All right, thank you, Hans. We're going to take just a brief moment to let our audience know that we are taking questions on social media with the hashtag AskNASA on Twitter. We're going to get to those in just a second, but we want to go to the phone now for an opening statement from Kurt Costello, the chief scientist for the International Space Station. Kurt, are you with us?
Yes, I am. Thank you, Daryl. I'd like to point out that our SpaceX CRS-17 flight is going to be delivering 1,700 kilograms of research cargo and supplies to the space station, including 2 new external payloads, the Orbital Carbon Observatory 3, OCO-3, and the Space Test Program Houston 6, STP-H6. The International Space Station is an amazing multidisciplinary lab supporting all types of research and technology development, furthering our NASA goals to advance our human exploration capabilities, return benefits to people here on Earth through our partnership with the National Lab, build a low Earth orbit commercial marketplace, and continue to work with our international partners. Today, I'll be going over a few of the investigations with you. In the area of biology and biotechnology, the National Laboratory is flying 4 separate tissue-on-chip investigations. These are being done in collaboration with the National Center for Advancing Translational Sciences at the National Institutes of Health. The investigations are looking at 4 different biological systems using microphysiological systems and live human cells. This eliminates questions that may arise sometimes when we're using animal model systems, and it may allow for multiple samples to stow and be flown in limited hardware space with a minimum of crew interaction. The first of these experiments is the kidney cells experiment. This will examine how kidney health is affected by microgravity and other factors of space travel, including increased chemical exposure, water conservation and recycling, and altered dietary intake. Serious medical conditions can be caused by poor kidney health, including proteinuria, osteoporosis, and kidney stones. These occur more quickly in space. Knowledge can help protect the health of astronauts and contribute to better treatments for kidney-related conditions on Earth. This is coming to us from the University of Washington and the Kidney Research Institute. The second experiment, the lung host defense in microgravity, explores why the space environment makes astronauts more prone to sickness than people on Earth. It uses an organ-on-a-chip technology to create three-dimensional models of lung and bone marrow, and then purposefully infects those lung cells. The response is measured in the bone marrow and the bloodstream and is compared in the microgravity situation to that on Earth. This investigation is coming to us from the George S. Werther's MD Children's Hospital of Philadelphia. The third of these investigations is studying the blood-brain barrier in an organ on a chip. The blood-brain barrier is an important physiological feature to understand how toxins and nasty stuff in our blood is prevented from entering our brain and causing inflammation and disease. This particular investigation will be looking at better understanding neurodegenerative diseases such as Alzheimer's and Parkinson's. This comes to us from Emulate Bio in Boston, Massachusetts. And finally, the last of these tissue-on-a-chip investigations is the cartilage bone synovium microphysiological system using the MVP, or multi-purpose variable G platform. This investigation is looking at the effects of musculoskeletal disease on biology, motivated by a disease called post-traumatic osteoarthritis, in which a traumatic joint injury may lead to arthritis or the loss of cartilage and bone. The ability of potential drugs to treat the progression of this disease is going to be tested in both space and on Earth. From the biological side, we'll switch over to the physical sciences side, where we have a new facility being flown on board called Hermes. Hermes is an experimental facility that holds cassettes about the size of a Pringles can. Many different types of science can be done in this, but the Hermes Cassette 1, the first of these investigations, will be looking at asteroid building and regolith. So many small particles are placed in these cassettes, and video is taken of them as they expand on orbit and self-sort. It's interesting to look at these in the microgravity environment to get a better understanding of how asteroids and other space-based bodies come together dynamically. External to the ISS, we'll be flying 2 new payloads in the trunk of the Dragon capsule. The first is the Orbiting Carbon Observatory, or OCO-3, and it will be installed on the Japanese Experiment Module exposed facility. This is designed to observe and measure the total carbon in a averaged carbon column as it flies over various parts of the surface in a 50 by 50 mile swath. This can be used to look at phenomena located just in one area, or over time to build up a map of all the carbon sources and sinks. This is related to the free-flying investigation, OCO-2, and uses flight heritage equipment from that program. Also, we have the Space Test Program Houston 6, which is comprised of 7 separate payloads. These payloads are focused on advancing technologies, including advancing our space-based supercomputing capabilities, determining the attitude and position knowledge from nanosatellites, measuring the space plasma charging environment and air glow in the upper atmosphere. There's even an investigation looking at X-ray communication testing. So a very multi-talented payload external to the space station. Our last category of payloads that I wish to talk about are our student and educational payloads that also fly in Dragon and bring the next generation of researchers into the spaceflight community. NASA researchers are also looking into the effects of microgravity environment on biology in the microalgae biosynthesis and microgravity experiment. This studies the effects of microgravity on Hematococcus pluvialis, an algae capable of producing a powerful antioxidant. It is hypothesized that this algae will be able to produce more of this antioxidant, and it could become an in situ resource available for future space exploration. This comes to us from the Des Moines Area Community College in Des Moines, Iowa. And on our national lab side, the Genes in Space 6 competition winners will be flying their payload as part of the National Lab Science Complement. Genes in Space 6 looks at the yeast, Saccharomyces cerevisiae, and its ability to repair double-strand DNA breaks due to environmental damage. This is the first investigation that is looking at creating that damage in space so they can look at the hypothesis as to whether the repairs DNA undergo in space are more error-prone or less error-prone than those that we undergo on Earth.
All right, thank you very much, Kurt. And before we continue, we want to get a little bit from the weather, the biggest story of the hour, and that goes to our launch weather officer, Will Ulrich. Will, we hear some rain on the way.
Thank you, Daryl. Normally, I'm not the bearer of bad news, but I kind of feel like I am today. Unfortunately, we've been monitoring an area of disturbed weather over the Bahamas for the past few days, and that area of disturbed weather is encroaching upon the Space Coast this afternoon and tonight, and it will be very near the area overnight tonight, so we will be looking at a higher than usual chance of shower activity, slightly lower chance of lightning activity, but plenty of clouds that will kind of throw a kink into the plans for this afternoon, or for tonight. If we take a look at the satellite imagery right now, you see that area of disturbed weather over the Bahamas. It continues to slowly move to the northwest, and it is expected to move over the area later tonight and overnight tonight, bringing an unusual surge of moisture for this time of year. Atmospheric moisture values are near record values, unfortunately, overnight tonight, and that will kind of feed into the possibility of multiple levels of clouds and shower activity. We're also monitoring another storm system out over the central United States, stretching from about Chicago down into the Texas area. That storm system will remain far enough away to not have any impact on our local weather. However, it will direct that storm system that's currently over the Bahamas. It will move in our general vicinity before getting kicked out ahead of that storm system currently over the central U.S. So this is the time of year, May, where we typically worry about afternoon showers and thunderstorms, but with the presence of this storm system over the Bahamas, this disturbance, as it moves over the area, we are anticipating a higher than usual chance of showers overnight. So if we take a look at the forecast, the launch forecast for tonight, we do have a 60% chance probability of violation for three primary concerns, including the cumulus cloud rule, thick cloud rule, and flight through precipitation. Temperatures will be hovering in the middle 70s, which is not atypical for this time of year, and we will see a nice breeze out of the southeast between 15 and 20 miles per hour. I mentioned that storm system currently over the central United States. As it encroaches a little nearer to the Space Coast, it will push out that system beginning tomorrow afternoon. So the system that's currently en route to affect us overnight tonight will begin to move into the western Atlantic and offshore the Carolina coast, so that if we look at the backup day forecast, conditions are expected to improve as we see that moisture move out into the Atlantic and drier air filter in. We are, for probability of violation, currently forecasting 30% or 70% go for launch. Still concerned about the same three constraints, including cumulus and thick cloud rule and flight through precipitation. However, as you can imagine, we're just not expecting as many clouds and showers in the vicinity of the spaceport during that time. Temperatures also hovering in the low 70s. So I wish I had better news for you folks, but hopefully we can find a gap and around that time and get this rocket up.
All
Thanks.
right. Hope so. Thank you, Will. And now we're going to turn it over to questions. We have some reporters on the phone as well as social media, but we're going to start here in the room. I just want to remind you to wait for the microphone to come to you, raise your hand, state your name and affiliation, and to whom you're going to direct your question. And so we'll start now with Marcia.
Marcia Dunn, Associated Press, for you, Hans. What does the accident do to SpaceX's effort to get astronauts flying on the Crew Dragon this year? Is that even a possibility anymore? Just sort of a look ahead at what you're, what you anticipate, and also a status of the landing zone. When do you expect that to be back in action?
Yeah, so for the overall program, I mean, first of all, we're going to learn a lot, and I think this will make the program actually safer at the end of the day. In terms of schedule, I feel like that resolving this, finishing the investigation, resolving this anomaly is actually our prime focus, certainly for me right now. So we will see also what comes out of it to some extent. Yeah, so what I'm saying is it depends a little bit on what we find and what shapes the schedule ahead of time. I hope this is a relatively swift investigation at the end of the day, and I don't want to completely preclude the current schedule. It's certainly not great news for the schedule overall, but I hope we can recover. And part of this is also based on the fact that we have multiple spacecraft in work. Basically, we started production, so we have several spacecraft in different shape and form right now with respect to that, so that we don't turn around and build a new one now. This is basically already in the works the entire time. Yeah, so. I hope we can mitigate that impact on that. And then your question regarding the landing site and test site were very close. We wanted to basically make sure that we can focus on the evidence and not disturb that, and make sure that we analyze this properly. That's why we separated the landing basically. We are pretty close to we can get back to the site right now overall, but we can't get close to some of the to the test stand basically on Dragon itself. So there's still some safety precautions right now for certain areas where we can't get to. But I also heard we're getting close, and we're getting close to basically get full control of the site. But I've heard that for a couple of days too. So it's going to be day by day.
If I could just follow up. Do you believe that SpaceX will be able to launch astronauts on a Dragon by year's end? At this point today, if I were to just...
Yeah, I know what you're saying. If I personally believe that, I certainly hope so. It's a complete carte blanche when you start investigations of that. Yeah, I've done this a couple of times. I've done a lot of anomaly investigation by now, and whatever I knew in the second week was never really what happened to be the result in the end. So this will take a little bit more time.
All right, next question, Chris.
Chris Gebhardt with NASA Spaceflight. 2 questions for Hans. I'm wondering, are there any operational changes to how the recovery teams for the booster have to operate landing it at sea, but this close to Port Canaveral with all the cruise ship and commercial traffic? And also my standard question, what's the precise launch time down to the second?
Right, let's start with number 2. It's 3:11:33. However, that sometimes shifts in the last couple hours, so if you see something else, that's not me, it's just the station. Exactly. So with respect to the recovery operations, I want to say it's harsher for the team to be on a trip a couple of days out and then do it there and then come back in a couple of days. It's certainly easier the closer they are to the shore. Makes it more benign. Their cell phones still work. So, but the protocol itself and the procedures we do are the same here.
All right, another question from the room before we go to the phones. Ken, in the front here on the right.
Hi, Ken Kramer, Rocket STEM Space Up Close for Hans. Can you talk a little bit more about how you investigated, and maybe Kenny Cott too, the commonality between the Dragon 1 and the Dragon 2? How were you able to confirm, talk about the investigation, how are you able to confirm that there isn't the commonality that would cause a problem? Okay, there must be other things besides the Super Dracos that are in common. And the other thing I want to ask you is about, you said just now you can't get to the test site. Can you talk a little bit about why that is? Is it so contaminated that people just can't get there except in suits or whatever? Thanks.
Sure. So how do you do this in general? You look at the list of components on both spacecraft basically, and there's a team that actually reviews the what is on the configuration on both spacecraft, and so they have all the necessary information and data to see if parts are the same, if parts are changed, if parts operate in a different way. So we have this basically as part, not quite that, but part of our review for each launch is to go through the list of components, make sure they're qualified, make sure they have the right pedigree, and so on and so forth. So there are teams in place that can do this relatively quickly. I can tell you that I personally reviewed some of the data to make sure that, for example, the scales are properly calibrated, and so there's a lot of work went into that, and a certain amount of brainstorming to make sure that we did not miss anything, obviously. Then one factor is also, keep in mind, this CRS-17 was also the same spacecraft that flew on CRS-12. Regarding the test site, there are several hazards. For example, there's still pressurized CUPVs, which in terms of CUPVs is a good thing if they hold pressure that long, right? But we got to be cautious, make sure that all safety protocol is being adhered to. We also should point out that we're working with the Air Force to make sure this is safe for personnel.
All right, we'll come back to questions in the room in 1 minute, but we want to take a question over the phone now. And caller, we are actually having a call from James Dean from Florida today. Go ahead, James.
Thanks, Daryl. Yeah, Hans, even though these are for different programs, is it difficult for the CRS team and Falcon teams to press ahead with a launch this quickly after such a dramatic mishap as we just saw with a different capsule but similar?
I don't think so. We had time enough to answer that question. We had people that addressed the question of separation between the programs specifically. We're going very systematic on this test anomaly. It certainly is something that is, is shock to some engineers, obviously, and I also want to point out that there's always this positive thing of learning things and making things better. But overall, I feel like we're ready on CRS-17. The team is focused on that. We're a big company, and I feel Cargo Dragon is safe to fly to the station. So is Falcon 9.
All right, another phone call reporter. We have Samantha Massanuga from the LA Times. Samantha, are you there? Do we have Samantha on the line?
Hi, sorry, my line was on mute. A question for Hans. Can you talk a little bit about what exactly happened when Crew Dragon was on that test stand? I know there's that leaked video showing what appears to be a fireball. Is that accurate? Thanks.
Yeah, I can't comment on a video that wasn't produced by SpaceX. I will not mention that. And then regarding what happened on the test stand, like I said, it happened after we did a successful test on the Dracos, and just before we wanted to go into a test on the Super Dracos. We have tons of data, and we're sitting over this, but we don't have currently something where we can say, oh, it was most likely this or that. We do think, I think it was not a Draco, Super Draco thruster itself, but that's pretty much all I can say at this point in time. It will take some time for us to go through the data and figure out what it was.
All right, and just a reminder that we are taking questions for CRS-17, so we'd like to keep those specific to that, if you will. Let's go over to social media and find out what's happening on Twitter. Rachel?
All right, we've got a cute one with a gif of a sleepy girl blinking. And Mitchie Kastner wants to know, why are you launching in the middle of the night? I mean, I will wake up to watch, but dang. Could you explain a little more?
Well, as Hans said, it's all about orbital mechanics, and unfortunately, that's something we can't control. Station's going to be where it's going to be, going around the Earth, and at certain times of year, this is where we find ourselves. This is the optimum point. A lot of the time, you're trying to manage the performance on the launching vehicle. You want to be able to put as much cargo on there as you can. So the quicker you can get to orbit and get in behind station, that's what we want to do, because that allows us then to maybe not fly as much fuel, and maybe we can put more cargo on. So it's an optimization problem, but it's driven primarily just by orbital mechanics. So and I feel her pain. So
and I
often
I do want to point out, it's actually I like launching at night to some extent. The weather is usually calmer, so for us it's actually good.
Usually, yeah. All right, and we'll go back to the room here. Stephen in the front here.
Hi, Stephen Clark from Spaceflight Now. Hans, another question on the anomaly earlier or last month. You mentioned the anomaly occurred during the activation sequence for the Super Draco, so I'm curious if you could talk about the Super Draco pressurization system, what happens during the activation system, what happens during that activation process, rather, and the role of COPVs in that process, and just walk us through what's supposed to happen during that process.
Right. So, I mean, it is basically what you do during activation is you pressurize the system and you make sure everything's primed in. You open valves, you close valves, and regarding, well, that's basically what a activation system does, right? Regarding COPVs, you do not pressurize COPVs at that point in time. You actually take pressure away. I want to point out the COPVs are different from Falcon 9. These are different material. They have a different form. I'm fairly confident that the COPVs are going to be fine. But again, like I said, I was wrong in the past two after a couple of days, and you look at it longer. But it's I want to say there's still several COPVs there. So.
All right, very good.
Just a quick follow-up. We heard during the ASAP meeting, I think last week, about vibroacoustic loads during this test. Were you doing any testing in the vibroacoustic environment during the activation?
Yeah, we did do some testing with, I forgot, I don't think we did it with this particular Dragon, but we generally do vibroacoustic testing in a test chamber, so we know things are basically designed for that environment. That test itself, when you fire thrusters, is also a good test for that, but we didn't get to this point. Yes, exactly. We weren't at the point where the thruster would create vibroacoustic noise at that point in time. Like I said, this is all pretty new for us in a sense. The investigation is going on. I don't have a lot of information where this is going, and every guess that I would give you would probably just turn out to be the wrong guess in the end anyways, unfortunately, yeah.
All right, in the back, Melanie Holt.
Thank you, Daryl. Melanie Holt, WFTV, and this is regarding the anomaly, so you have to forgive me. I haven't heard an answer to this one yet, though. You were talking about a different propellant for the crew. Dragon versus the cargo Dragon. Can you talk to us a little bit about the propellant that would have been aboard the Crew Dragon? It's been described to me as hypergolic. Just kind of what that is, and that orange tinged smoke that was seen on April 20th. I mean, how is that contained to the site where everything obviously occurred?
Let me, there's probably a misunderstanding. It uses the same propellants as propellants itself. The propellant system is different. In other words, and in particular, the one main difference is that Dragon 1, or the cargo Dragon, does not have super Dracos and a propellant system, a propulsion system rather, that has a high flow, thicker lines, basically, is what it boils down to, yeah? But it does have the same Draco system, which it uses for orbital maneuvers and for attitude control. So it is very similar in that aspect, and uses the same propellants. It also uses less. There's more on Crew Dragon. So overall, there's some commonality, but the system that we believe, if we are kind of looking at closer here, is not one that is on on cargo Dragon, for the next flight.
Obviously, when you see that smoke, I know there were no injuries clearly, but how do you contain all of that to the site where that happened?
Right, so public safety was not at risk at all. We make sure that the wind goes from the right direction in those tests too. And the orange cloud that you see is an NTO at the end of the day. But it is safe once it disperses in the atmosphere to really, once you mix it basically with air at a reasonable rate.
Okay, let's go to Reuters. Second row on the left.
I haven't been with Reuters for a while. Irene Klotz with Aviation Week. That's okay. Thanks. The forgot my question. Two questions for Hans. First of all, were the Super Dracos tested at all on Demo 1?
Sorry, the system on Demo 1 was isolated and never was never used on Demo 1.
And of the 600 Super Draco tests that you mentioned, were any of those with equipment that had been in the water previously?
No. Actually, that's a good question. Because we had the paddleboard too, and that was in the water. So I can't answer that question. Possibly.
Okay.
Yeah.
And have you
But I do appreciate you staggering the questions so I can actually remember them too.
Thanks. And have you been able to eliminate anything like ground support equipment, contamination in the lines, anything that has come off the fault tree?
We did, but the fault tree is pretty long, and at this point in time, those are preliminary, I want to say preliminary judgments, but we do need to still collect evidence. We need to make sure that we don't miss anything from any of these sources. So right now, we got to keep an open mind and make sure that we consider basically everything.
We're going to go back to the phone bank now. We have Mary Beth Riggs from The Verge on the line. Mary?
Yes, hi. Thank you so much for doing this. I'm curious if you have any idea how this might delay test flights going forward.
Yeah. I feel like I'm running the same answer every time a little bit, because I don't know what happens coming out of the investigation. Basically, I don't know what the impact is to the spacecraft. Is it a small change? Is it a big change? Is it an operational change? There's all different solutions that can come out of that, and they obviously drive the schedule because, like I said, we do have Dragon in production at this point in time, and that basically mitigates the impact. But if you have to go back and make changes, then obviously that's going to cost some time. So it's really, I'm really sorry that I can't give you a good estimate on how much this would delay, or if it delays at all. It's just depending on what we find and where we go from here.
All right, another phone question. We've got reporter Marina Corin from The Atlantic. Marina?
Speaking, but am I on the line now?
Yes, go ahead with your question.
Okay. Hi, thanks for doing this. This is a question for Hans. Have you or anyone else at SpaceX spoken to Bob Behnken and Doug Hurley since the anomaly? And what would you say in general to kind of reassure them based on what happened with the capsule?
You know, it's actually interesting. We did talk to Bob and Doug, of course, and I almost feel like they were very sympathetic and reached out to us. So I almost feel like they are encouraging us right now, and they're helping us in getting keeping our motivation and not fall into a hole basically, and get worked up over this, but rather stay focused and get the investigation going. Don't miss anything. We work with them very closely. I feel I can always go back and ask them to help me motivate the team and get this done basically in the most safe way we can possibly do. Yeah.
Okay, we're going to come back to the room. Any questions about CRS-17? Over here in the corner. Thank you.
I'm not sure if this is for Kenny or Hans, but if the weather doesn't cooperate for the next 2 days, what's the range availability? Are there any station issues that might affect your launch options?
Well, we know for a fact that we have the 3rd and the 4th. The challenge is going to be after that, the range has a planned stand down for the next week. So we'll pick up on the other side if we have to. But I don't, once we get on the backside of that, I don't know that there's any huge constraints that would keep us from pressing. We just got to get through. So hopefully we can get off to today or tomorrow and we don't have to worry about it. But if so, we'll have to pick back up sometime the 12th, 13th time frame.
Emery, over here.
Question on the anomaly, Hans. How many seconds before the planned ignition did the anomaly occur? Can you say, give us some idea of the time frame?
I want to say half a second.
And so we'll go to the middle of the room at the 3rd row back. Emery Kelly with Florida Today. Go ahead, what's your question?
This is not CRS-17 related, I'm sorry. Hans, Dragon 1 and Dragon 2, can we just get a Dragon 2 is 95% unique components or 5%, is there any kind of way of quantifying how similar they really are that so the public can kind of understand that?
It's a really good question. I wish I would have paid more attention to that earlier to answer that. I want to say it's really, really low probably. I would call this, it's a heritage design. In other words, the same engineer who designed something for Dragon 1 designs a better system for Dragon 2 based on the experience that we had on Dragon 1. But I think there's only a few parts per se that are really the same, yeah.
Let's come over here to the right side of the room. Celebration News, I believe.
Hi, I'm Jim Siegel. I'm with Spaceflight Insider. I have a question about if there is a weather delay, are there any cargo that need to be replaced because of the delay, because they're perishable or whatever? And regardless of whether that happens or not, does the rocket go horizontal and then put back vertical tomorrow, or how does that work?
Well, from a cargo standpoint, our science, right now we're good for the 3rd and the 4th. So if we have to recycle after that and then go to the other side of the range downtime, then we'll be refreshing at least our samples and so forth. Absolutely.
Okay, so does the rocket just stay vertical on the launch pad then, or does it come back down?
Go horizontal to allow the access to the signs.
So that's going to happen regardless of whether anything is replaced in the cargo hold.
Sorry, maybe I misspoke a little bit.
Okay, so let's say...
I assume right now after 2 days we would need to have access to the cargo.
Sure.
And that means the vehicle needs to go horizontal and then, yeah. And, yeah.
I assume it would remain horizontal until we get ready to try again.
All right, so if it's delayed 1 day...
If it's delayed 1 day, we're fine.
The samples that we have on there now are, everything is good to go for both the 3rd and the 4th.
And so the rocket stays vertical.
Correct.
Yeah. Okay, thank you.
All right, let's go back over to the left side of the room. Over here in the middle, young lady has a question.
Hi, Jabali Herrera with the Orlando Sentinel. I'm sorry, Hans, this is about the anomaly too. I'm just wondering whether you've determined at this point whether any of the anomaly was in any way related to the demo test, if anything that happened there could have affected this test that you were having on the 20th, if any of that was related to.
Sorry, are you asking if this mission has an impact on?
If the anomaly was in any way impacted at all by the test that you did in March,
the previous flight?
the demo one, yeah.
Yeah, I don't think so. Frankly, it's a system that, like I said, it was isolated during the flight, basically. But it could be an interaction. It could be some really subtlety then that is related to that. But I wouldn't put this as on the top of my list of issues at this point in time. But it is certainly something that we need to look into. And likewise, that it was in the water and recovered. All these things need to be looked into.
Chris, you have a follow-up question?
For Hans and Kenny, maybe. NASA there were a string of CRS flights for NASA that used flight-proven Falcon 9 cores, and I believe this is another brand new core for this flight. And I'm just wondering, 2 back-to-back brand new core flights, was there something that changed within NASA's thinking about using flight-proven cores, or is this just luck of the draw where the missions happen to fall on the schedule?
Yeah, from my perspective, there's nothing that's changed in our thinking on that, on how we're doing flight proven.
I love the question why we fly new boosters. Obviously, it's a good question. Every once in a while, we need new boosters. It's that's how I would phrase it, basically, just to replenish the fleet and keep it fresh. But it is interesting how the thinking changed overall, that we went from, you always fly new boosters, right, and you throw them away, to suddenly, why is this actually a new boosters versus a reused boosters? It's a very interesting way of how the thinking changed and in the world of space.
Gentlemen, up in the front here on the right-hand side.
John McGill with Wyandotte Cable and News. This one's for Ken. As far as on the space station with the bus, do we know if that was just a failure of the bus, or was there something upline or downstream that caused it?
At this point, it's hard to tell. If you look inside that box, it has a power supply. Based on the testing that we did post-failure, just in situ, trying to command certain components within the box, it has an internal power supply, and our best guess is right now that it's the power supply in that box that drives all these valves. And the fact that we were still able to talk to the box but not command the valves inside the box kind of leads us to think it might be that power supply that specifically drives those valves. And so that's what we're thinking right now. But at the end of the day, it didn't provide us the function we needed. So we'll bring it back home at some point and try to figure out what really happened. But that's our lean right now is the power supply.
Okay, and I have one on weather related, so we wake up. As far as CRS-17, when that one went off, there was lightning off to the south. Is this the same type of weather pattern, or how big a hole are we looking for?
Sure. We have different standoff distances that we look for. Typically, with regards to the pad, we're looking for 5 to 10 miles away from the pad, any type of lightning activity. But we also have to take into account the path that the rocket goes up until it gets into the stratosphere and far enough removed from weather on the ground. But typically, we look for a 10-mile standoff away from that flight path. That storm that you referenced, I believe, was the CRS-16, you said. That was, I believe, we estimated around 30 to 35 miles away. So while it looked pretty in pictures, it had no impact on operations for us during that particular mission.
All right, and we'll take one more question before we wrap. Stephen?
I had 2 quick ones, I hope, for Kenny and Hans, one each. Kenny, what's the current target date with this delay of a couple of days? What's the target date for Dragon's departure and reentry? And Hans, can you tell us when your next launch might be after this?
Sure. The thinking right now is probably at the end of the month. I brought that just in case here. We are, if we get off on the 3rd, we'll probably somewhere around the 31st of May is what we're thinking right now. But we'll we'll have to reevaluate that. Typically, the way the process works is once we get off the pad and get to station, we have to get all the science out. That takes some amount of time, and our duration is mostly driven by what does it take to get the science done. Some of it has a minimum duration, and then some of it has a maximum duration. So we usually meet with the SpaceX team about a week into the flight and start laying out, what do we think. But if you put your thumb in the air right now, you'd probably say at the end of May.
And regarding the next launch, I would look at mid-May at this point in time.
All right, gentlemen, thank you very much for your time and answering the questions along with your patience. And we're going to wrap up the press conference for today. As a reminder, the launch is scheduled for Friday, May 3rd at 3:11 in the morning Eastern Daylight Time. Our launch coverage here on NASA television starts at 2:48 in the morning. And you can learn more about the mission at nasa.gov/SpaceX and at nasa.gov/station. Thank you.